Greetings, everyone. Thank you for joining us at Exchanging Ideas 68 Global 5G Evolution. I'm 𝗃𝗂𝗶𝗰𝗲, the founder of Global 5G Evolution, and giving a warm welcome to all the speakers from all over the globe. To the audience, please take a couple of seconds to click the subscribe button on our YouTube channel. Now, let me introduce our first speaker, Shahbaz Ali from Barcelona, Spain, to present the impact of 3GPP NTN IoT field test on the global IoT ecosystem. Over to you.
Thank you very much, everyone. I'm Shahbaz. I'm the Vice President of Products and Standards at 𝗃𝗂𝗶𝗰𝗍. So today I'll be explaining you what are the recent impacts on the ecosystem for the 3GPP NTN field test that we have done. A brief about us, we are 𝗃𝗂𝗶𝗰𝗍. We are the world's first 5G NB-IoT LEO satellite operator. We are working in the IoT space and also direct-to-device. Our role, what we are playing now is the validation of the terrestrial satellite interoperability under 3GPP standards. We are currently focusing on running some field pilots with the standard compliant interfaces and the ecosystem enablement. Quickly on the LEO-NTN architecture, as I mentioned, we are operating in the low Earth orbit. We are targeting from 3GPP release 17 and above. The validation role that we are currently doing is the interoperability between the terrestrial and the satellite networks within the 3GPP format. What is demonstrating is the cellular IoT devices, they can directly connect to the space-based network like us. So that's what we are currently validating. We are running field pilots, and in the next slide we'll see with a commercial chipset. And this field pilots, which we are running, are having a very great impact on the ecosystem enablement, and we see the commercialization very soon. So what we have done, we have done the field test with the Nordic Semiconductor with the model nRF9151. This is the world's first LEO-capable chipset operating on 3GPP release 17. This is commercially will be soon available. Already this is available to order since a quarter. On the chipset side, the dev kits are going to be available also very soon starting from next month or so. So this chipset and module, this supports 3GPP release 17. It also supports the NB-IoT, LTM on the terrestrial side, and this is working with our constellation. We are regenerative payload supporting in the LEO orbit, and we are handling the ground segments accordingly as per our strategic locations. So what are the test conditions and the constraints that we have seen? We did this test in the S-band. We are operating in the S-band, commonly used for satellite operations. And then the validation approach, which we adopted, that we started with the lab demonstration, lab emulation first, and then we went to the field test for over-the-air validation. As far as the device roadmap is concerned, this is based on Nordic nRF9151, and the current, as we are speaking now, the current firmware is available for testing. We are running some great pilots across the globe with different customers, with different operators. And as I mentioned, early 2026, it will be commercially available to buy and to run different IoT projects. What are the key implications on the ecosystem? We have seen from the device feasibility perspective, so this has helped to prove the feasibility for the unmodified commercial IoT devices over NTN. When we say unmodified, of course, this is backed by the standard 3GPP release 17. So this is the power of the standard. That's how it's working, and that's how it's creating the device feasibility for the ecosystem. So the existing IoT hardware that can connect with the satellite operator, nRF9151 from Nordic is an existing chipset. So that's the power. That's the only work that was done by Nordic, of course, when they certify the device with us. So they work on the front end, on the firmware side only, which helps to use the existing device ecosystem to be capable for the NTN. What it does, that it eliminates the cost for the hardware modification. This is not a new hardware; it's an existing hardware. So existing chipsets supporting the terrestrial connectivity. Of course, if they are capable to be upgraded to 3GPP release 17, through a firmware update, they can start being used in the commercial setup. We talk about the clear interfaces. So this validation helped us to validate the interfaces for the ecosystem stakeholders. We are talking about the device vendor, the NTN operator, the protocol stack of the developer. So now what we are doing now is working with the IoT solution providers, that is the end customer, which is validating this all ecosystem on their application side. So they are working with us also, with Nordic, to validate their applications to support the non-terrestrial connectivity. So this is very powerful because this helps the developer community, the NTN IoT solution provider community, to understand how the switching between the non-terrestrial and terrestrial will happen. What are the implications on their application side? I'm talking about the device application for the moment. So what are the implications on their application side? So how they need to handle the device satellite prediction when the satellite passes are happening. We are talking about LEO, the satellites are moving. So there are lots of parameters which the application needs to handle. Of course, this is very powerful. We see a lot of excitement in the industry now. The validation is happening. We are validating lots of use cases, talking about agriculture, mining, forestry, oil and gas, and also some of the other use cases. So this is generating a lot of useful insights and learning for us and for the community as well, which is helping us to generate an input to improve the product for the customers, like IoT solution providers, and also which is helping us to foresee where the industry is heading to and what are the new requirements which are popping up. So yeah, this is more or less from my side. Thank you very much. Thank you for the opportunity. And if you have any questions, you can reach out to me. Please connect to Ganesh or connect me on LinkedIn, and I'm happy to answer your questions. Thank you very much.
Awesome. Thank you so much. Really appreciate that. And let me introduce our next speaker, 𝗧𝗲𝗶𝗰𝗍 from Gen, Belgium, to present on the promise of interoperable SATCOM challenges and opportunities. Over to you.
Thank you, Ganesh. Thank you, Shahbaz, as well, for a nice overview on what you're doing on IoT and narrowband IoT. So what I'm going to talk about is about the promise of interoperable SATCOM, but then looking more from the broadband side and the challenges and opportunities linked to that. So I'm 𝗀𝗲𝗏. I'm the VP Business Development of NXG SAT. So maybe let's start a bit with a comparison, right? How does satellite communication, broadband satellite communication, look like today? And can you imagine how it works, right? Can you imagine how a terrestrial network would or your mobile services would work if you have devices which are not interoperable? If it's just a closed vendor-locked system, when you have a device, it can only work on one operator network. If it's like all the networks are running on dedicated hardware versus having software-defined hardware, and it's not cloud native, right? It's not scalable, and networks are deployed still very CapEx heavy. While of course you would expect that today communication systems heavily use cloud systems and roll out networks in the cloud, in a cloud native environment, right? So this is how the satellite communication for broadband looks like today, right? Very closed system, dedicated hardware on the remote side and on the central side. And that's exactly what we believe 5G NTN will change and what we are focused on. So that's to deliver that interoperable satellite communications, enable flexible deployments, enable software as a service models as well, so that operators, customers can integrate the best technology possible. Now, what we are focused on is on the 5G NTN SATCOM modem, to make that flexible, to deploy it on custom off-the-shelf hardware and appliances, so that it can be easily rolled out. But at the same time, we have to keep in mind, of course, what is so important for satellite communications, and that's the energy efficiency and the bandwidth efficiency, right? To make the business case work, those are two key performance indicators, if you want, that are so important, and that's what exactly NXGSAT is focused on, is to make sure that 5G NTN technology works in the best possible way from an energy and a bandwidth efficiency at the same time. Now, if we look a bit back and forward, right, on what's in the market today, and then what 5G NR NTN, broadband satellite communications could be. So this is what you see a bit on a side-by-side comparison on the main drivers, right? You see legacy SATCOM, you see in the middle Starlink LEO, right, which is omnipresent today in broadband satellite communications, and then you see what 5G NR NTN SATCOM can deliver as well, right? So maybe let's just walk through them quickly. From a broadband performance, you can see that all three technologies, if you want, have the same capability in the end, right? It's just a matter of allocating the resources, using the resources, but all three can deliver the right performance. A second important element for a lot of verticals is also how you can manage QoS. You have to have an enterprise-grade QoS management. And there you see that legacy SATCOM had a lot of capabilities built in there, but not fully standardized. Starlink LEO has very limited capability to do really enterprise QoS management. It's more a broadband consumer-like service. And you see that 5G NTN there can deliver the promise as well, because that's exactly what's built in the whole 5G ecosystem and solution. Both the legacy 5G NR and NTN SATCOM can deliver that multi-orbit NGSO GEO capability. Of course, Starlink is a LEO-only solution, comes with its limitations. Starlink kind of sticks out from a service price. Why? Again, because it's a consumer-grade service, right? It's made for the mass volume. Comes with the pros and the cons. One of the pros is that service prices are very attractive, where legacy SATCOM and 5G NR and NTN SATCOM are less focused on. As well, but then you can see as well where the real differentiations lie, right? Security capabilities, sovereignty, right? To have isolated networks, which is a very hot theme today. So that's where legacy SATCOM, of course, has played very strong. We believe that their 5G NR NTN even is stronger because of the inherently built-in security. So in the past, there have been a lot of security breaches with legacy SATCOM because it was kind of not built for security. We believe that's where 5G NTN makes a difference. And then last but not least, of course, is the full standardization, interop roaming capability, and the flexibility to deploy fully software-defined solutions, both on the remote side as well as on the G Node B side, is a massive differentiator, of course, for 5G NTN. Now, let's look a bit at a couple of use cases, right, where we see the convergence of 5G non-terrestrial and terrestrial playing a very important role. So the first one is the use case about ships, maritime market. What are the drivers there for this hybrid connectivity? Yeah, you have port to sea to port type of connectivity. So you may use terrestrial network, then use satellite, then use again terrestrial network. So that's where the roaming capability comes into play to switch between those networks. Even a more advanced case is what we see from users is when they have vessels on inland waterways. Yeah, sometimes there is connectivity terrestrially, sometimes there is not. So there is a need to have more frequent switchovers between terrestrial and non-terrestrial, which to make it really effective needs a seamless switchover. So that's one of the challenges that we still see. And of course, they also need global coverage, any place, any time, which typically happens to multiple providers using both GEO and LEO-MEO capacity as well. Another use case is a bit similar, but then it's more for the IRO market as well. So what's there kind of the need? It's again from the gate to the gate connectivity, from the airport to the airport connectivity, where if the plane is located at the gate, it can use the local infrastructure, potentially the wireless network. But of course, once it's flying, it will have to use the NTN connectivity as well. One of the key challenges here as well, which the IRO industry has been facing when it comes to satellite communications, is user terminals, right? User terminals have been very vendor locked in. So the antenna on the top of the plane is a specific vendor. So that's where really a unified, universal multi-orbit user terminal is key. And I know Airbus is working, for example, on a project which is enabling a more universal user terminal for NTN satellite communications. Then another one, again, a use case of hybrid connectivity is think about critical infrastructure. So it's about security, it's about resilience, but there as well, typically it will use multiple means of connectivity, be it wired connectivity, be it terrestrial wireless connectivity. But then, of course, to have that resilience for the critical infrastructure, so that high availability, that backup capability, that's where the satellite NTN comes into play. What is here important, again, a bit the same themes as before, but add on top here that time to market, agility to address needs and threats from a cyber security is one additional driver. Just a bit to sketch a bit the scene on different use cases where we believe NTN broadband will really make a difference compared to what is available today from a legacy SATCOM perspective. So that brings me to kind of the main slide as well, right? Two elements which are very important, the standards and the interoperability. So there we have the 3GPP standardization of 5G NTN, which is further evolving the 3GPP standard to enable that fully interoperable, standardized environment. So that's built on 3GPP release 18/19 for that broadband connectivity, maybe some part in 20 as well. Unification of the terrestrial, non-terrestrial services around the 5G core, and then 5G core roaming, which comes natively out of that. It provides then flexibility to choose your service provider. So it gives customers or telcos or end users more optionality, who they want to work with. Native built-in security. And then, of course, there's also that 5G ecosystem. There's the economy of scale to reuse what is available as well from overall 5G providers and deploy that to your right size and scale, I would say, in non-terrestrial networks as well. What is one of the challenges there that we see remaining? Yeah, the seamless roaming across terrestrial, non-terrestrial networks still needs work. And so that's not a common thing, let's say, in terrestrial networks, right? So this will still need some further work, probably in the standardization as well, to make that seamless roaming happen over time. On the other side, what value do we bring as NXGSat? As we said before, it's all about software-defined UE, but also to bring that performance and efficiency from a user terminal perspective. If we have 5G technology, but we cannot deliver the services in the best possible way to drive the business case, then it becomes challenging, right? So that's what exactly we are doing with our expertise from the SATCOM, combined with our expertise from 5G NTN. We are making sure that user terminals will perform in the most optimal way. So that's the combination of the antenna and the modem jointly, right? It's not because you have a 5G stack that it will work efficiently. One of the challenges that we still see there is that there's also a standard for the digital interface, which is interfacing between the UE and the RF, the antenna electronics, which is called the DIFI standard, but that's still maturing. So there's vendors coming to the market. So that ecosystem is still advancing. But you can see in the combination of both things, that's what we are doing at 𝗃𝗲𝗱. So thank you for your time. If you have any questions, feel free to reach out. And this is 𝗃𝗲𝗱. So we're a Belgian company founded in 2024. So we're a startup. And we have tremendous amount of expertise in the SATCOM ground segment and user terminal. A lot of our colleagues are former NewTek iDirect. Thank you for your time and look forward to the rest.
Thank you, Joe. Really appreciate it. Let me introduce our next speaker, Florian Thirion from Toulouse, France, to present on Airbus vision for 5G non-terrestrial networks. Over to you.
Yeah, hello everyone. Good to talk to you today. My name is Florian Thirion, and I work for Airbus Defence and Space as the head of marketing for secure connectivity within the space digital entity. This entity provides end-to-end solution for ground segment, for providing terminals on the move, on the pause, and also providing SATCOM services based on military and governmental satellites, but also on the commercial constellations. So today I will present the basics of 5G non-terrestrial network and what it means for Airbus.
Florian, if you don't mind, would you mind to change the config to full slide?
Sorry. Is it better now? Ganesh, is it better?
I can't see your slides.
Sorry for this. Can you see it now?
Yes, sir. Now it works.
Okay. Sorry for this. So let's start with a reminder. We use telecommunication every day. So, for example, each European you use almost 15 satellites daily. So first, as you can see on the first use case, as a backup for terrestrial network, and this is a very suitable use case for 5G NTN. So, for example, for 5G, it is today accessible mostly in the big cities. So the satellites will extend the coverage, for example, to the countryside, to the maritime, to the Arctic regions, and also for people abroad. So, for example, for the military during their overseas operation, but also for researchers, for explorers. From our perspective, there are two types of 5G NTN. The first is backhauling. So here, the satellites will be a relay in space, providing and receiving the telemetry from the 5G core networks and transmitting all this data to land or maritime user terminals directly to the 5G terrestrial network. And we have also the pure 5G NTN. Here, the satellite acts as again a relay in space, but here the satellites will provide the data from the ground segment, from the 5G core network directly to mobile terminal and directly to small devices such as a smartphone or PC, for example. To give you an overview and a summary, so 5G non-terrestrial network and terrestrial network will form the basis for a full 𝗃𝗂𝗶𝗰𝗸 convergence. They will provide three main applications. So, for example, in K and Q band, they will provide connectivity data for VSAT, for all the very small aperture terminals. They will provide as well in L band terrestrial connectivity and data to, as I said, smartphone and small devices. And also, it is very suitable for extending the coverage of massive deployment of sensors and asset tracking for everything about Internet of Things, IoT. So what does it mean for Airbus? So it means first providing a seamless, resilient, and secure global communication, reinforcing mission readiness and sovereignty for end users. It's also it means being ready for the 5G transition in terms of developing a fully digital payload, ensuring flexibility in terms of reconfigurability in space, in orbit, and today Airbus is working on it with OneSat, for example, on brand new satellite, fully digital. And we will continue to develop digital payload and regenerative payload in the future to be fully 5G and 6G compatible. So to embrace this change, Airbus is active in the most of the key standard developing organization. First, 3GPP. Here we are a member to provide any information and to support the 5G, 6G architecture and protocols. We are also very much involved into the TM forum, everything about network and service management, and we are participating to the DeFi consortium for everything about digital interoperability of the space industry. And you know, Airbus Defence and Space is very much linked to the defense and the military and governmental domains. This is why we are very much involved as well in NATO standardization, participating to the standards for secure communication military solution. Now about the use cases. So 5G NTN is essential for mastering complex operation and situations. So for example, for maritime surveillance, we think that 5G will provide and enhance the massive deployment of IoT sensors on the sea, over the ocean, for situational awareness, for having more data about the oceans. Same for in terms of military purposes or catastrophe. So it will enhance the way we communicate with headquarters. For example, having a better extension of command and control performance via satellites. Same for the UAV and drone command and control. It will support reliable communication and resilience of the communication in terms of command and control for all these UAVs and drone. And network survival. This is very key. So after an earthquake, after fire, after flooding, for example, 5G NTN we provide the connectivity and restore of communication after a failure or catastrophe. Benefits and next steps. So in terms of 5G benefits, we think that 5G NTN will be a true catalyst for truly global and resilient communication. So if we look first, it will allow a massive data transfer and a low latency, so a very high speed connectivity, and the possibility to exchange a very large file. It will provide global connectivity and enhance the collaboration. So with satellites, we can give the data everywhere in the globe, including in white areas, and the ability during catastrophe or during military CONOPS to create cross-country groups to be more interoperable. optimization of the radio resources with digital payload, with more flexibility, with a better allocation of the beams and the resource. Yeah, it will improve and optimize the radio resources with dynamic allocation, both from the ground and from space, improve the resource management in terms of satellite operation. And it will the 5G ecosystem will allow as well custom optimization due to the fact that it will drive innovation, and for sure it will simultaneously reduce the cost. We think also that with this 5G NTN, we'll have optimized operation and affordable access to the 5G overall network. So everything, having the full 5G ecosystem will allow to reduce the cost as well at the end for both operation and also the way we operate satellite for our customer. Now I will this is the last slide of my presentation. So I just wanted to give you the last news about 5G NTN on our side. We have conducted a demo recently together with our partners, Eutelsat, a group of industry partners such as Sharp, Mediatek, and others, and ESA. And we've managed to successfully transfer the 5G signals to a group of satellites in low Earth orbit using a specific method, the conditional handover. And this method allows a quick and smooth and dependable switching of the 5G satellite from one fast-moving satellite to another. And this was a great achievement, a big step for us to go forward in combining ground-based and satellite network on the low Earth orbit. And it brings us closer to having a reliable 5G coverage all around the world. So it was, again, a big step for us, and we will continue to conduct demo with our partners to prove that it is feasible. So I just wanted to summarize as well the Airbus value proposition in that field. Airbus will be able at the end with 5G NTN and the 5G terrestrial network to provide end-to-end and highly secure and resilient and sovereign solution that integrates 5G NTN capabilities into the complex 𝗲𝗲 architecture and solutions that we are providing to our customer. So thank you again for your attention, and if you have any question, it will be my pleasure to respond to or any questions that you may have. Thank you.
Thank you, Florian. I really appreciate that. And I would like to introduce our next speaker, 𝗲𝗂𝗶𝗰𝗲 from London, UK, to present on small cells and NTN, common challenges and common solutions. Over to you. Vicky, are you there?
Yes, I am.
Right.
Sorry. Yeah. Can you see my slides?
Yes.
Excellent. Okay. Well, thank you very much for the invitation to present. So 𝗲𝗂𝗶𝗰𝗲, VP of Product Management at 𝗀𝗃. We're a UK baseband SoC company providing 5G solutions and also 4G and looking forward to 6G. I'm also a work item lead and a board member at Small Cell Forum. And today I'm going to talk about the paper that Small Cell Forum that I've co-led have done on NTN and how it overlaps with small cells. So I will move on. Okay, so why was Small Cell Forum interested in NTN? So we have small cell networks Obviously, there are a small coverage and small capacity, whereas NTN networks are large coverage and large capacity. However, there is the group has identified certain overlaps, where particularly around constraints of size, weight, and power. The need within 5G for NTN for standardized interfaces. And then there's other areas that Small Cell Forum are active on in terms of sharing technologies such as neutral host and policies around spectrum sharing. So myself co-led the paper along with Rob Maunder from 𝗀𝗃𝗏𝗃, and also the Small Cell Forum chair 𝗃𝗶𝗏𝗃 helped lead the work item. You can see that there's quite a lot of players within the satellite industry, including micro-amp radiosis and Marvell. And we've also got input from Andre, who manages the 𝗲𝗃𝗶𝗰𝗙 interface, looking to the roadmap inputs for that going forward. So the paper is focused specifically on NTN, 5G NTN solutions, particularly around regenerative, where the network elements are hosted on specifically LEO satellites. So we looked into the standards, so the 3GPP standards, also of applicable standards, and looking into the roadmap for the 𝗲𝗃𝗶𝗰 interface. We looked into the components and the need for space grade and how COTS devices that were designed for terrestrial could be used. And then certain partners, including 𝗀𝗃𝗏𝗃 and Radisys, have been looking into handover technology as well. And then we get some case studies from 3 of the vendors, the contributors as well, looking into aspects of providing that technology. So we've covered already the different sort of use cases and benefits of NTN. What this paper also looks at is how that maps to connectivity type, whether it's direct to device or indirect, whether it's wideband, broadband, or narrowband, and also the UE terminals that are available that work with those use cases. So focusing on the RAN side and the GNOB side, we look into the different architectures that are suitable for NTN applications with 5G, and starting from the current sort of deployments where the GNOB is residing on the ground station, and the satellite just has the transponder providing a bent pipe, a transparent interface to provide the signal. Then there's also the partial regenerative. So this is where the DU and RU resides on the satellite, and the ground station has the CU, and this is using 3GPP interfaces such as F1 in the link up to the satellite. Then there's a fully regenerative interface where the whole GNOB resides on the satellite and connects to the ground station using the 3GPP NG interface. But there's also certain use cases that may be suitable to have the user plane functions within the satellite as well. So that was also discussed. So as I mentioned, we looked into the requirements and the risks for devices, GNOB devices, semiconductors that are residing on the LEO payload, and what the impact additional environmental conditions would be. So radiation, more extreme thermal cycling, the additional risk to ESD damage, and there's obviously the vibrations and vacuum outgassing, which can affect particularly at launch of the satellites. So most terrestrial COTS devices are qualified to JESD 22. And there are looked into the different standards defined by NASA and also the EU that are applicable for components in space. And we have seen that already that an NPU, the NXP LX2160, has been qualified and screened for space by a third-party vendor, Teledyne. And so this sort of sets a benchmark of what is possible to be able to use COTS devices in space. Another thing the paper looked into was handover. So the cells on the Earth that are projected by the beamformers, there may be different options on how they are fixed and how they get handed over. They may be a fixed beam that doesn't move as the satellites move relative to the Earth, or they may be sort of move along with the satellite. Either way, handover is required between the satellites, and so the member teams have been looking into this. This affects the layer 2-3 software and also the beamforming control between the layer 1 and layer 2 using the 𝗲𝗲𝗄 interface. Another thing that we looked into was the beamforming architecture. So there's different options available there. On the top diagram is analog beamforming. So the baseband provides a interface that goes converts at baseband, and then the beamformer is fully analog, either FR1 or FR2. In the middle diagram, we've got just digital beamforming. So all of the beamforming is done in the digital domain before it's converted to RF. And then finally, there's hybrid beamforming, which does a combination of analog and digital. So this is the sorts of areas that we need to look at in terms of how the 𝗲𝗲𝗄 interface works to support the control of those beams, as we mentioned, for creating the fixed cells and also handover, etc., being able to direct those beams. And finally, the paper is going to be published on Thursday. So there'll be some news about it. There's a press release going out. So it'll be available on the Small Cell Forum website. So please subscribe, and I will put a link when it is available onto the YouTube link. There's also going to be a webinar with the lead contributors doing a deeper dive into the paper, and that'll be in the middle of January. And also the next, the team are looking at the feature, adding the NTN features into the next 𝗲𝗲𝗄 release, which is likely to be published the first quarter of next year. So that's everything from me, and please get in touch if you have any further questions. Thank you.
Awesome. Thank you, Mickey. I really appreciate it. And let me introduce our next speaker, 𝗱𝗃𝗂𝗶𝗰𝗸 from Singapore, to present on global satellite IoT market outlook on technologies, use cases, and innovation trends. Over to you.
Thank you, Kanesh. Yeah, you can see my screen, right?
Yes.
All right. So, hi everyone. Hi, I'm Rachel. I'm an industry analyst at ABI Research, and I focus on space technologies. So today I'll be speaking from ABI Research perspective on the global satellite IoT market outlook, elaborating more on the technologies, the use cases, and the innovation trends in the space. So let me just dive right into it. Right. So before we dive deeper into kind of the trends and technologies of satellite IoT, it's worth to ask kind of why do we need satellite IoT, right? What value does it bring to the industries? What value does it bring to different sectors? And also how can satellite IoT support different business operations? Because these are basically what businesses want to understand, the value that it brings so that they can adopt it and implement it for their operations. So firstly, satellite IoT, we can see that it serves more than just remote sensing. It can be implemented and used in many different industries and sectors, shown here, such as agriculture and forestry, construction, mining, and transportation as well. So all these can increase business efficiency, and there are many other sectors not mentioned here, such as maritime for container tracking, or automotive and energy and oil and gas sectors as well. But basically, satellite IoT can really help to speed up processes, operations, remote data collection, route optimization, condition monitoring, and also many other use cases. So, for example, other companies such as like 𝗾𝗶𝗶𝗱, they offer low data satellite IoT connectivity used for agriculture and forestry monitoring. And then OPCOM as well, they provide hybrid satellite cellular IoT for fleet management, container tracking, mining, remote asset monitoring as well. And Vodafone also has their own satellite IoT branch, which focuses more on industries like utilities, banking, retail, oil and gas, environmental monitoring, and agriculture as well. So, of course, it's versatile and is satellite IoT can be used in many different industry verticals. So, of course, another key reason for satellite IoT is its ability for global coverage, including in remote and rural areas. So for example, there's mobile applications like fleet management shown here, or container tracking that they can often require devices to travel in and out of areas without cellular. And this also applies to supply chain and logistics, transportation and trucking sectors. And of course, with these type of applications that is mobile, it will be more if a customer has a mobile use case that requires kind of seamless transitions, it will be valuable to choose hybrid cellular and satellite connection. But on the other hand, there is also use cases like power transmission and pipeline monitoring in remote areas that are kind of more standalone instead of mobile, and that would be more applicable to 𝗲𝗲/NTN. So ultimately, there is also kind of a price and power that comes into the equation. And depending on the use case scenario, companies will more or less choose the most efficient type for their operations. So speaking about, after discussing more about what the value satellite IoT brings, we want to know kind of how can we make satellite IoT more viable, right? How can we increase the adoption and implementation of it? So first, the first point I'll make is we kind of need to change the economics and dynamics of satellite deployments, as launch costs are kind of a significant part of overall constellation TCO, the total cost of ownership. And ABI Research, we do a lot of market data and forecasting. So our latest recent market data satellite launch and constellation market data, we forecast that the global orbital space launches annually will reach about 485 by 2032. So launch costs are also expected to decline from about 2,300 per kg to about $300 or even lower with reusable rockets. And a lot of companies are innovating in this space. So for example, with Starship, the economics of launch will drop to roughly about $300 per kg, around 10 reusers of it. So as we see more and more companies kind of innovating and developing their launch technology, the launch capacity is also continuing to increase. So there's efforts from SpaceX, Rocket Lab, Blue Origin. There's also Chinese companies as well in the equation, such as Land Space, iSpace, Galactic Energy, and others. So the demand and network deployment plans will still currently exceed the supply projections because a lot of companies are still kind of in a more trial phases right now. And of course, satellite design is also expected to shift to more software-defined and regenerative architecture, where capabilities can be updated by software, new waveforms, new image processing algorithms. They can stay commercially useful longer, even as markets or standards evolve. And they can reduce how they need to be replaced with new launches, therefore reducing kind of the cost as well as to make satellite IoT more viable. So hence, the first point would be to change kind of the economics and dynamics of satellite deployment. Second point would be on standards. So I know the previous speakers have also spoken a lot on how significant the standards and how interoperability it brings. So of course, there has been a lot of changes in the 3GPP releases every couple of years or so, and the standards will definitely bring greater interoperability as platforms, terminals, modules, chipsets adhere to them. So with NTN standards enhancements like the IoT NTN, it will allow the ubiquitous connectivity and interoperability for economies of scale. And this ultimately will lead to lower hardware and service costs as well. So in this way, the platforms, modules, terminals can work on many different types of terrains like through land, sea, and air, even low altitude economy like the UAV or drones, high altitude platform stations as well, maritime as well, ships, and also land vehicles. So some companies are already following these 3GPP standards for NTN. There is the IoT NTN and the IoT standard, or are actually also actively working towards it. So some examples will include Iridium, Skylo, Satel IoT, previously mentioned by speaker as well, and Space42 via SAT as well. So this is also one way that has already been in to make satellite IoT more viable in this case. So speaking about standards, we talk about there's also a lot of satellite IoT competition is ramping up as the market is moving towards the 3GPP standards, as I was mentioning earlier, because the 3GPP standards and also the LoRa Alliance are driving a lot of new opportunities for satellite IoT in the space. From our forecast, it is projected to have around 31.5 million IoT connections by 2032, which generates around about US 7.1 billion in annual revenue. And so these are just some examples of the different IoT NTN operators and the different LoRa NTN operators and the frequency bands that they operate in. So I wouldn't go much detail into it. But basically, it just shows that the competition in the satellite IoT space is ramping up as the market is moving towards standards, while of course not forgetting that there's also still proprietary solutions out there as well. So speaking about satellite, the competition that is ramping up, we also see it as like a rapidly evolving market with many new IoT operators entering the markets, including Chinese companies in the space like 𝗱𝗃𝗃 or 𝗾𝗂𝗶𝗰𝗙. Due to the increased competition as well, we can expect the cost of access to decline. As we know, there's increased capacity in LEO constellations. There's a lot of current companies that are really ramping up their LEO satellite networks. So the increased capacity will cause a significant decline in connectivity rates across industries. And this increased LEO capacity, particularly from SpaceX, Amazon, Globalstar, Eutelsat OneWeb, is expected to cause an average price decline of about 4.6%. And one of our forecasts is that we forecast that currently there's about 10,000 plus active satellites in 2024 in orbit. And this number is going to increase to about 43,000 1,000 plus active satellites in 2032. So this is in line with our current understanding of the FCC filings at this point in time. But on this note, Chinese-based companies as well are also ramping up on their LEO satellite network capacity, but they are not following the 3GPP standards. They are more towards following their own proprietary standards. And the 𝗱𝗃𝗂𝗶𝗰 with a target network of about 15,000 in total at the end, 𝗃𝗂𝗶𝗰𝗲 with about 13,000, and also 𝗃𝗂𝗀𝗶𝗃 with about 10,000. But basically what I'm trying to show, and my point is to show that LEO network capacity is increasing, and that is one area that is causing the cost to decline as well. And of course, there is a huge range of connectivity costs depending on the customer and the use case, the industry, and what you need it for. But in general, we can expect the cost to fall due to higher competitive pressure. So in terms of technological trends in the satellite IoT space, we have touched on the different standards being developed, the strong competition increasing from many different companies and regions. We're also seeing a lot of interesting innovations and developments as part of it. So each company will definitely want to stay on top of their competitors. They were increasingly innovating and advancing their technologies to develop higher capabilities of their products for their customers. So some key technologies are edge computing and artificial intelligence. They are increasingly becoming integrated with satellite IoT. And so this slide basically is to show some examples of companies adopting edge processing capabilities on their satellites to enable faster insights. They're implementing AI and ML systems on board their satellites to demonstrate real-time data analysis. So there are so many more companies not listed in these slides, definitely. So this is just more kind of a snapshot at a glance. But for example, Anduril is rapidly developing their advanced systems such as on-orbit edge processing data, edge processing of sensor data, and 𝗂𝗏 EO also plans to launch edge computing enabled satellites in 2026 to make EO data more commercially viable and efficient. And for artificial intelligence and machine learning, we can see that through these examples is actively being deployed and value adding in different industries, such as healthcare, like medical diagnosis in space, there's maritime, to track evasive vessels or container monitoring. There's environmental and climate monitoring as well for weather prediction, and so many more not listed here. So in this space right now, we are seeing many new innovations, developments in the satellite IoT space, and I'm sure there'll be more developments in the future as well, such as maybe hybrid connectivity models, combining terrestrial and satellite, improving satellite IoT module hardware like the size, weight, and power, and also multi-orbit connectivity, and so on. So just to summarize, we have touched on many different aspects. We have touched on the value of satellite IoT, how to make satellite IoT more viable, how to increase the adoption of it, the competition and the ecosystem around it, and also the technological trends surrounding it. So just a quick summary on this topic. Satellite IoT will provide coverage to areas that cellular cannot deliver, especially the rural and remote areas. And there'll be several vertical industries that can harness satellite IoT, but agriculture, construction, mining, and transportation will definitely be key drivers behind the technology. And of course, with new use cases and emerging opportunities in the new segments, there's bound to be a lack of knowledge where the opportunities lie. So marketing efforts and awareness campaigns from companies are usually what we are observing right now to help with educating the end users with the true potential value that satellite IoT can offer. And new constellations such as Amazon LEO, Telesat Lightspeed, Chinese constellations are going to be enabling new features, link budget, and low latency applications as well. And in terms of competition, I mentioned that there's rising competition, but in fact, there's a lot of cooperation in the space as well, and strategic partners are needed to accelerate satellite deployment. And last but not least, in the short term and currently, satellite IoT is kind of a complement to cellular IoT. However, as I've been emphasizing in my previous slides about making satellite IoT more viable with the increase in launches and the increase in LEO network capacity, satellite manufacturing, and increased functionalities, I think including the move towards 3GPP standards and how competition is rising, we can expect to see economies of scale that the demand can really transform in the next 5 to 10 years. So yes, that is all from my side, and thank you so much for listening. And of course, if there's any questions, feel free to reach out anytime.
Thank you, Rachel. Appreciate that. Let me introduce our next speaker, Vikas from Bangalore, India, to present on seamless Earth-to-orbit connectivity, 5G core as the heart of NTN. Over to you.
Yes, thank you, Kanishwar. I hope I am visible and my voice is audible. Please let me know when you're able to see the screen and I'll start.
Awesome. Working well.
Thank you. Hello, everybody. My name is Vikas. I'm Director of Product Line in Packet Core area, 4G, 5G Packet Core. Today's topic, thanks for the opportunity to Kanishwar on the topic of seamless Earth-to-orbit connectivity, 5G core as the heart of NTN. So basically, I deal with the product lines on the 5G core side, not on the satellite side. So I wanted to give an overview of how the 5G NTN impacts the 5G core. So today, there are nearly 14,000 satellites currently orbiting Earth, with about 11,000 active satellites as of May 2025, as per the reports. My colleague Rachel also mentioned about it. Thousands more are being launched every year, making space more crowded and more critical than ever. Just to give you some highlights and catch up today, we would be covering the following agenda: NTN, what and why behind it, unified architecture, challenges, security mechanisms, NTN key use cases, beyond release 17 3GPP, and 6G view. So today, there are several dozen commercial satellite operators, as I said, worldwide, with operators in around 20 plus markets already, rolling out NTN services. Leading names include Starlink, which is SpaceX, SES, Intelsat, Eutelsat OneWeb, Iridium, Viasat, Hispasat, Niasat, ABS, Thycom, and SkyPerfect JSAT. So you can see the satellite industry booming with 5G NTN being implemented. So what is 5G NTN and why it matters? 5G NTN integrates satellite and high-altitude platform systems directly into the 5G ecosystem. This is not a separate network, but just an extension of standard 5G connectivity. You could also refer to the diagram towards the right, where you can see the satellites orbiting the Earth, connected to the ground stations, the NTN gateway, the 5G core box here below, and also the data network. So what are the key advantages of 5G NTN? The major advantage is service ubiquity. I am sure many of the speakers also covered this. Just wanted to emphasize that the service ubiquity actually means the reachability in rural areas, airborne areas, maritime, which is extension of 5G NR to spaceborne platforms. So as you can already identify, many of the satellite types have been covered: LEO, MEO, and GEO, all play its own role in 5G NTN deployment. Next is service continuity. Basically, non-terrestrial and terrestrial network continuity is very important. I am connected to 3GPP network and also connected to satellite network. So this continuity of the service is very crucial when 5G NTN comes in. This enables satellite access to integrate seamlessly with the 5G core network as well. Supports transparent and regenerative payload architectures. We provide mobility, QoS, and service continuity across orbits, foundation for direct-to-device satellite communications. Moving to the next slide, there are multiple NTN variants and their coverage. Just to give you an overview, there is LEO, MEO, GEO kind of satellites, there's 𝗶𝗶𝗰𝗋, and also UAV drones. Basically, 5G NTN network unlocks global interoperable standards-based space connectivity. This is pretty much covered by and powered by 3GPP release 18, 19, and further NTN enhancements, designed for satellite operators, telcos, and enterprise service providers. Just to give you an overview of these types, LEO satellites, HAPS, and UAV has their own altitude coverage, typical coverage, and primary use case. If you can see for maritime and remote IoT, LEO satellites cover an altitude of 500 to 1200 kilometers. 𝗶𝗶𝗰𝗋s cover 20 to 40 kilometers, and UAVs cover up to 15 kilometers. So each one is used for their own use cases. Primary use case include maritime, remote IoT, rural broadband, event coverage, and lastly, the tactical operations disaster response. So basically, as an operator, you can think which NTN variant aligns best with your current coverage gaps and why. Coming to the architecture at a very 40,000 feet level, we have transparent payload, which is the bent pipe. The satellite merely acts as a repeater. The G node B, which is a base station, remains on the ground, connecting to the satellite via a feeder link. The red color arrow is the feeder link. This is the current standard. Coming to the 5G core side of the world where I come from, crucially, the same 5G core manages both terrestrial and satellite access. That means from 5G core perspective in the diagram below, if you see this 5G core cloud, it is very seamless. So it doesn't matter to which connection it is connected to. From the 5G core side, it only sees the satellite path as just another radio access network. That means for both satellite core and 5G core, it is the same single core. This also is very beneficial for operators. The core challenges, these are the three core challenges. There could be a couple more. Just pressing on important ones. High propagation delay. Satellites are thousands of kilometers away. The 5G core and RAN need to handle round trip times, as you can imagine, from 30 millisecond to 600 millisecond. That is from LEO to GEO. These also affect timers and retransmission logic. So on the 5G core side, we have AMF, similar to MME 4G world, which needs to handle all this handovers as well. The Doppler effect, the fast-moving LEO satellites creates significant frequency shifts, which means while pre-compensated at the device or RAN level, the 5G core must also handle the resulting rapid handovers. As I mentioned, there are multiple handovers that needs to be handled at the AMF. Moving cells, unlike fixed ground towers, satellite beams move across the Earth. This means the AMF must track users without overwhelming the network with constant updates. The satellites move across multiple areas, so there is a quick handover also which is happening. So the below line which I have put for thought is what regulatory or technical hurdle is most urgent for your organization and who could help remove it. Just think about it. On the 5G core network functions, there are multiple functions which get impacted, AMF, SMF, and UPF. On the mobility management, AMF handles the registration and mobility over moving cells, as I mentioned. Session management provides and adapts QoS flows for higher latency environments. It ensures sessions persist even when switching between satellite beams. So even during switching, the SMF anchors the session and holds the session tight. The user plane function is deployed at the satellite gateway or even on board satellite in future to reduce latency by keeping traffic local. I wouldn't get too much into details as this slides will be shared. Basically, all aspects around multi-connectivity, multiple RAT, seamless interworking, unified authentication, security, NTN-aware mobility management, the SMF function routing the N6 interface to NTN gateway, and QoS-aware packet forwarding with dynamic latency budgets are all covered by this feature. Moving to security enhancements, we reuse the comprehensive security mechanism defined for 5G terrestrial network, which means there is nothing new that we need to define for 5G NTN, and it can completely reuse whatever is already present. As you can see, there are multiple aspects of 5G security, whether it is subscriber privacy around 5G QT or 𝗧𝗂𝗶𝗰𝗍, the control plane security aspects like NAS signaling, integrity protection and ciphering and encryption algorithms, user plane protection between UE to G node B, encryption integrity protection, AKA, which is authentication and key agreement with mutual authentication, unified access control, inter and intra-network security, inter-PLMN security with serving and home networks and home network controls, and intra-network security, which is basically dealing with service-based interfaces, which is HTTP2 based, and also non-service-based interfaces, which are bit legacy, and also with NG-RAN interface like FE or E1. Coming to high-value NTN use case, a lot of other speakers on this call already covered many of these use cases, but wanted to highlight key use cases here. As you can see on the ship, which is maritime, airborne, and also rural areas, there are multiple use cases and its value proposition. Maritime connectivity, which is 24 cross data for shipping, safety critical alerts, has a feature in itself which is multi-connectivity and low latency slice. Remote mining and exploration, this is the value proposition for this is real-time telemetry and autonomous drilling. The 5G core feature for this would be the edge computing on the HAP and with high throughput. Aviation and space on the flight, we get in-flight broadband, telemetry, and satellite relay. These are possible with dynamic handover inter-satellite links. Rural broadband, which is a famous use case on this call as well, has a value proposition of 5G coverage in underserved areas. This is the primary use case of 5G NTN for satellite operators to reach the areas which are not very well covered. This is achieved using hybrid NTN core spectrum sharing. Last but not the least, disaster response with the value proposition of rapid network deployment, IoT sensors. This is as part of the 5G feature called onboard have rapid provisioning slice. So basically, which use case as an operator you want to see as a quickest path to the commercial pilot needs to be decided. What are the strategic benefits for satellite operators? Basically, the standard based interoperability with 5G operators globally, lower operation cost, basically the lower OPEX using cloud native 5G orchestration, access to billions of 5G devices via standardized NTN support, rapid service launch using 5G ready ecosystem and chipsets. This was also one of the topic covered by previous speakers. Flexible monetization using slicing and differentiated QoS tags. Basically, we can have a dedicated slice for 5G NTN, dedicated slice for 4G NTN, and we can also have differentiated QoS. Partnership-ready architectures for multiple telcos and hyperscaler environments. So basically, we have strong differentiation versus proprietary satellite systems. Gone are the days with proprietary satellite systems. Everything is evolving with 5G NTN, which enables 5G grade QoS, mobility, and secure authentication. The roaming aspects also touched upon with respect to the seamless mobility. There is some work to do here from standard chess as well, but seamless roaming between satellite and terrestrial 5G network is the in thing. Future-proof evolution towards 6G space networks, last but not the least, opens the path to large-scale IoT, hybrid networks, and device-to-device. Finally, looking into the future, also as a foundation for 6G, there are a lot of things coming up as well from NTN perspective. 6G and generative payloads, the evolution continues with 3GPP release 19 and beyond. Future satellites will carry regenerative payloads, as I mentioned, effectively putting the G node B and UPF in space. This enables store and forward capabilities and direct satellite to satellite routing, creating a true internet in the sky. That is the ultimate aim of the NTN as per 6G. So some of the key points here I would like to highlight is device-to-device satellite messaging and broadband becoming mainstream, AI-driven beam management and dynamic routing across orbits, NTN IoT, one of the concepts of NTN, which is advanced concept, the IoT for NTN aspects of the IoT scaling to millions of devices globally. Just like for GCIoT, NB-IoT, there is an NTN IoT as well, adding more value to the 5G NTN. Unified satellite, terrestrial architecture in 6G, space networks becoming an essential extension of national 5G infrastructure. So whatever 5G infrastructure has been provided country-wise, nationally, the space networks in each country is becoming very essential as well. 6G will build on 5G and likely achieve Mbps peak data rate and sub 1 millisecond latency. This is one of the last slides I want to cover, highlighting services and targets going forward as well in 6G. Digital replica or digital twins, as you might have heard, this is very important service from 6G point of view for NTN. High fidelity holograms at scale, energy harvesting, coordinated swarms of drones, sensing as a service could be a big service as well. Targets, as you can see, the 4G speeds, 5G speeds, and on to 6G, there are targets with peak data rate, which could be like in terms of terabyte TBPS and with least latency. For example, just put Y microseconds, it could be like 1 microsecond or sub minimal microseconds here. And also energy harvesting also results in Z number of years long battery for selected IoT device. I've just picked an example here. It could be like long battery life up to 8 years or 10 years and so on. So this is the overview of 5G NTN from the core side, from 5G perspective and also 6G perspective. So from concept to commercial deployment, how does things run? So we always need joint R&D labs, the operators, like customers, like satellite vendors, and academia can all come together. Standard setting push contribution to 3GPP and our satellite, 5G SA IETF drafts. Pilot programs, we always launch multiple pilot programs, identifying 1 or 2 verticals. It could be maritime or rural broadband. Regulatory advocacy, harmonizing spectrum licensing for LEO or HAP devices. Talent and knowledge hub, 5G NTN white papers, workshops, and trainings. Some of the speakers were also speaking about the contribution in this area. So what is the first concrete action your team can commit to over next 90 days depends on multiple roadmap initiatives. Whether it is end of 25, you take it iteratively to end of 26 and 2027 plus based on release 19 specifications. So this is the list of key items I wanted to cover. Over to you, Kanishka. Thank you.
Awesome. Thank you, Vikas. I really appreciate for your contribution. Now, our next speaker, Stephen Ho from Singapore, to present on orchestrating what's next beyond clouds. Over to you, Stephen.
Good day, everyone. Can everybody see my slide?
Yes, sir.
All right. First and foremost, a big thank you to Kanesh for inviting me to participate in this very exciting conversation about 5G NTN. My name is Stephen Ho, Group CEO of 𝗧𝗲𝗶𝗰𝗙. And this afternoon, I would like to share our perspective, orchestrating multi-hybrid edge cloud in what is known as, in our lingo, orchestrating what's next beyond cloud. We'd like to take this opportunity to share some perspective of some of the work that we have been doing in terms of orchestrating edge, hybrid, and multi-cloud in the terrestrial 5G world. Just for quick context, 𝗧𝗲𝗶𝗰𝗙 is a software company, and we have been spending the last 10 years working with service providers like telecom communication providers, cloud service providers, governments, and enterprises to manage their data infrastructure across hybrid environment from cloud to edge. Our flagship product, Fusion Flow, which in a while I will introduce more, is allowing us to orchestrate these resources across the various environments. And our Connect Bridge solution allows us to orchestrate and virtualize secure network seamlessly across the global infrastructure network. A very quick snapshot on some of the deployments that we have done. Right now, our platform has been used to orchestrate and manage resources across some 200 data centers in 20 different countries, in excess of 1 million mobile subscribers. Now, all of us is aware of this trend. There's this explosive demand for AI infrastructure, and as alluded to by some of the earlier speakers, that there's definitely a shift towards hybrid and edge computing, even on the satellite basis, whereby AI inference model needs to be nearer to the source of data in order to have a faster response time in terms of processing. And we are seeing similar trends across a variety of domains, be they government, higher education, industry, or even end consumers. Now, what are some of the key challenges that is faced in this scenario? In our case, where we deal with 5G terrestrial network and working on MECs or multi-edge computing environments, we realize this increasingly the multi and hybrid cloud complexity is impacting a lot of our partners and clients. And for the service providers specifically, they are wondering and they are needing a way to figure out how they can introduce innovative and game-changing business models. And increasingly, of course, there's this concept and issue of data sovereignty, governance, and privacy. Certain data needs to stay in certain places, and how do we deal with that? And then even on terrestrial networks, adapting resources dynamically across different cloud environments as the workload fluctuates, it by itself is quite challenging. Now, if we were to introduce additional elements of NTN, then I guess that entire setup gets even more complex. And of course, for businesses, they do care about optimizing their costs, especially when it comes to using be they connectivity or even cloud. And of course, in the world of AI, any AI resource, the likes of GPUs, for example, is a scarcity. Then how do you democratize and fully utilize such resources? So these are some of the key challenges that we have seen working with our clients and partners. So a quick snapshot, what we have done, over the years is through Fusion Flow, our flagship cloud service platform, we are able to kind of put together varied environments, as you can see, service providers, public cloud, private cloud, public sector agencies, large enterprises, we can kind of link them up, and this allows them a unified platform to manage and utilize their resources, be they bare metal, GPU cluster, storage, VMs, or even virtual GPUs. And more importantly, perhaps, in addition to just orchestration, is the ability to have what we call billing capability, self-service possibility, and billing system capability. Now, if you really think about it, this is like a booking platform, right? The likes of perhaps Airbnb, where you can string together all these resources, and the end users can then very easily access all these varied resources in varied environments, be they at the edge, somewhere in between, or even amongst the hyperscaler, and then spin up resources very quickly on their own and keeping track on the utilization. Now, this virtualization, as I mentioned, allows very easy access. And more importantly, we are hardware agnostic. It doesn't matter what kind of hardware we're talking about. We can actually orchestrate them. And in terms of GPU scheduling, we are actually able to maximize the utilization of very expensive GPU resources by fitting more workload and compute using the same resources. Now, some of the key issues that we are really trying to address, and which we felt is very important, especially in this multi-hybrid world, is this whole concept of, how do you bring everything together in a seamless manner? So that's something that we are doing. And in terms of platform feature and user experience, we want to make it easy for any end users, be they enterprise or public sector agencies or even service provider. How do we bring them all together so that you take away all the complexity, and then it's as simple as just booking resources and on the fly. Now, in terms of security and governance, this is a very important topic, and we have designed our system to be very secured in a zero trust manner by design. And as mentioned earlier, this then allows service providers to have the opportunity to put together very interesting, innovative products onto this platform and offering it to their end customers. And of course, in terms of democratizing access, this also allows our service provider partners to offer GPU as a service, high performance compute as a service, or even AI infrastructure as a service. As mentioned earlier, different stakeholders have probably different focus in terms of their needs and requirements, and we are uniquely designed to meet the needs of each of them. So for example, in terms of public sector agencies or government agencies, they are definitely concerned about compliance, security, data sovereignty, regulatory compliance, and so on and so forth. Whereas for service providers, they would be very keen to have a seamless hybrid cloud, simplified management, software-defined networking, and unified infrastructure. Now, for large enterprises, we realize that they want to run smarter and save more. So they are very concerned about privacy and agility for sure, but at the same time, they do care a lot about cost efficiency, unified operations, and perhaps how to maximize any investments that they have made into those infrastructure. So specifically for service providers, global telcos, cloud service providers, or offerers of GPU as a service, what we are actually contributed to the conversation is the ability for them to scale with zero additional capex. They can leverage off their existing infrastructure and then form a cloud service around it. And by doing so, they can actually enjoy better margins and revenue control. They can set their own pricing, they can set their own business model, and through our secured high performance, unified networking capability, they can also offer QoS type of connectivity across global infrastructure. And then with them owning their own infrastructure, or for that matter, they can even form strategic partnerships with fellow infrastructure owners, and then string them all together and then offer it as a complete service or unified service to the end customer. This is one example of our partner, where through using the platform, they are able to very quickly offer a service. They can have a white label landing page. They can have a service portal. They have a very comprehensive billing system. And I apologize for it being a little bit small. They can even set up different SKUs or stock keeping units, whereby they can put together different combinations of compute resource, GPUs, and storage, and tag a price around it, and very quickly offer it to their end users. So in a nutshell, for Fusion Flow, we believe in one network, any cloud, and unified control. Through Fusion Flow at Skylab, we're able to connect together any environment, be they data center, public cloud, private cloud, edge, node application. We are able to manage any kind of infrastructure, be they compute, storage, GPU cluster, virtual machines, or even network, or any cloud. And ultimately, and this I guess is something that is very important for our clients and partners, they are able to deliver any kind of service. It could be an AI data center, high performance compute, government cloud, enterprise cloud, and hybrid cloud. With that, thank you so much for your attention. If there's any questions, comments, feel free to share it across. Thank you very much, and back to you, Ganesh.
Oh, that was amazing. Thank you so much. Appreciate that, Steven. And let me introduce our next speaker, 𝗧𝗲𝗶𝗰𝗲 from Paris, France, to present on safety and critical communications on NTN.
Hello, Ganesh. Can you hear me?
Yes, sir.
All right. Let me share. Can you see my screen, please?
Yes.
All right. Thank you so much, Ganesh, and a pleasure to be here with you today. So my name is 𝗧𝗲𝗶𝗰𝗲. I'm a co-founder of IFBW, which stands for Innovation for Better World. So we have founded IFBW almost 6 years ago with a simple and yet powerful vision: innovation for better world. But innovation is meaningless if it's failed when we need it most. So innovation for better world, we are mainly specialized for critical events management, for public safety, for military, for critical infrastructure, and we rely much on the connectivity. Indeed, with the evolution of the 5G, so it helps a lot. But as all we know that the ground infrastructure is still fragile, and in case of any disaster, simply we can lose that. So we are specialized. So we design and implement secure networks for public safety, military, industrial sectors, with a depth of expertise in backup solutions and service continuity during crisis. Then for security, I'm sorry, I need just to adjust this. I cannot see my. Okay, wonderful. Sorry. Okay, so our area of expertise is the public safety, police, fire, emergency, medical services, defense and military, secure communication in conflict zones, critical infrastructure like energy, oil and gas, transportation, healthcare, complex and international telecom infrastructure. In this world, crises can occur at any time. Critical communications are not an option, but a necessity. We think NTN networks offer the resiliency and global coverage essential for saving lives and protecting critical infrastructure. So our flagship solutions are integrated ecosystem. We offer a comprehensive range of technology solutions designed by our R&D. We have R&Ds in different countries to meet the challenges for critical communication in the most demanding environment. As I said, we have the solution for intelligent management of multimedia event for public safety, sensors, IoT, and so on. And we have the communication and the coordination tools, which is 3GPP MCS standard. And we have a complete solution end-to-end comprehensive management of the critical multimedia events with a centralized supervision. To define the critical communications or mission critical services. So earlier we had only the voice or voice only, which is the old technology, the radio-based technology. However, nowadays we make use of what technology offers. Therefore, we have the voice, data, videos, which will make let's say the coordination easier and smoother and decision-making faster. We use it for the public safety, as we said, as I said earlier, for the police, for the firefighters, emergency medical services, disaster response in case of examples, earthquakes, hurricanes, and so on. And we use the same for the military defense, secure mobile operations, especially in the non-covered zones and the critical infrastructure like the energy networks, the mine, the transportation, and healthcare. The key requirements for the critical communications. So we need a resilient network operations. Even in the event of a terrestrial network failure, we have to have a solution. And nowadays the solution is the NTN, where we are, even though the technology is not yet for a transparent handover between let's say the terrestrial network and the non-terrestrial network. However, we still can manage. We need as well the low latency. So the 5G is an example. Security. So we need the infrastructure to be secured, encryption from end to end, and indeed the mobility, support for moving drones, ships, and vehicles. Just some examples of why really we need non-terrestrial network. Because the terrestrial networks fails, or why land network failed. Vulnerability of the ground infrastructure, natural disaster. For example, in a blink of eye, 90% of the cell towers destroyed during the 2023 Turkish earthquake. The conflict zones, targeted or jammed infrastructure, the case of Ukraine. We all know about it. And remote regions where we have no coverage, like oceans, deserts, or polar areas. There are also where we need the NTN, the massive events. The mass event network overloaded during evacuation or attacks. Indeed, so there is no solution to cover the entire world unless the satellites. The ground infrastructure will never be able to cover the entire Earth. So LEO, MEO, and GEO satellites covers 100% of the Earth, including oceans and poles. The example of Starlink, where they have, I guess, around 8 million active terminals in 70 plus countries. Resiliency and dependent operations from ground infrastructure, resistance to disaster, jamming, and cyber attacks. Good stuff. So it's the low latency, so providing within the requirements of the critical communications, so between 6 to 30 milliseconds versus the 280 milliseconds for GEO for real-time coordination, and indeed the total mobility. This is real action, real cases. The war in Ukraine. So there was challenge. The challenge is terrestrial networks targeted by the Russian forces. Solution, Starlink provided military and the civilian connectivity where they can use, let's say, the real-time drone surveillance, secure command communications, public internet access during the outage, and so on. The second one in Turkish, 2023, there was the earthquakes, where 90% of the cell towers collapsed within a blink of an eye. So the NTN Iridium Starlink enabled coordination of each and rescue hospital communications for triage and government updates to the public. The impact is the response time was reduced by almost 40%. Then the third example is the maritime emergencies. Challenges, of course, no coverage on the high seas. Solution, LEO satellites, OneWeb, provides SOS messages for ships in distress, weather alerts to avoid storms, tracking ports in high-risk area. So the impact was plus than 10,000 lives saved annually via satellites SOS. Technology is driving critical NTN communications. The 5G, so far the release 17 of the 3GPP extension, the extension of terrestrial 5G to satellites, support for smartphones, IoT, and emergency devices. The encryption, so the encryption is there, quantum resistance algorithms, the direct devices or phones. Satellites connect directly to phones. No special terminal required. This is, advantage and of the NTN. AI-driven routing, dynamic prioritize emergency traffic, predict and avoid congestions. Challenges and solutions, overcoming the obstacles. Critical communication depends, or let's say one of the keys is for the critical communications is the latency, and therefore the high latency provided by the GEO satellites. The solution today is LEO and MEO. Deployment cost, shared constellation, Starlink, and OneWeb. Spectrum regulation, thanks to IoT and 3GPP standard for the global harmony. The terminal size and the power, that's another challenge. And so the example of the flat panels, it helps, using the solar energy and reducing, let's say, the need of energy. And the security risk, the encryption, the end-to-end encryption, and indeed the artificial intelligence monitoring. The future enhancements we are looking forward is the 6G and NTN, so the ultra-low latency, less than 1 milliseconds, and the AI native networks. Multi-orbit networks combine LEO, MEO, and GEO for seamless coverage. Future of critical communications. We're expecting a massive deployment of 5G NTN direct-to-phone became standard between 25-27. 28-30 hybrid NTN and terrestrial 5G, 6G networks, seamless handover. And hopefully starting 2030, the 6G NTN legacy less than milliseconds, holographic and communications, massive IoT, and the market potential is quite huge. The critical communication over NTN will be soon and essential as 112 or 911, saving lives, securing nations, and connecting the unconnected. The key take notes from my side is critical communication save lives, but terrestrial networks fail in times of crisis. NTN offer global connectivity, resilient and secure for emergencies. Concrete examples prove the impact. The examples we spoke about, Ukraine, Turkey, and maritime operations. The future, I think the future is bright. 6G direct to phone and AI will make NTN even more powerful. So I think, the connectivity is a human right, especially in an emergency event. That's all from my side, Kanish. Thank you so much.
Thank you, Fatih. I really appreciate that. So let's do this. Let's have a 10 minutes a quick Q&A discussion. I would like to request all the speakers to switch on your cameras, and we can do a quick brainstorming. So I think we have spent earlier discussing the most exciting frontiers, which is the fusion of space and ground networks and what we call the non-terrestrial networks. The vision is clear. We are offering a truly ubiquitous connectivity globally, whether you are on a mountain or a sea or in a densely populated city. The integration of LEO satellites with our existing terrestrial 5G infrastructure is the key to realizing the vision. And achieving this vision, however, is not just about launching satellites. It's about making the two systems, one fixed and one moving at high velocity, works as a single seamless network. In the recent days, we have noticed the most popular big tech hyperscalers have been announcing news of the space data centers. I think this is going to be the future in the next decade. So having said that, we know that this system requires a unified 5G core orchestration and ensuring that a user session, whether voice call or a data download, never drops as a move between a LEO satellite beam and a terrestrial cell tower. So that brings us to the most critical roadblock here. When it comes to dealing with LEO constellation, we are managing objects that orbit the Earth at like 27,000 km/h. And this creates massive complexity for the control plane. So let's turn around to our panel. My question is for the panel is, what is the single biggest technical challenge to achieve a true unified 5G core orchestration and seamless session handover between the LEO-NTN and terrestrial networks today? Anyone wants to take it up?
I think maybe I could start. Yeah. Okay, so I think the biggest technical challenge is from what we're seeing right now is probably the real-time mobility, and due to the highly dynamic environment of LEO satellite networks and constellations like what you've mentioned, right? Especially for the mission critical high-value use cases as well. So maybe like autonomous vehicle networks, drone operations, remote healthcare, and telemedicine, live broadcasts as well. So, and because in terrestrial 5G, the base stations are kind of like in a fixed locations, like you mentioned. So handovers are predictable and relatively infrequent. But in contrast, the LEO satellites move kind of thousands of kilometers per hour. And so they force the device on the ground to switch satellite every few minutes. And of course, this creates the rapid and frequency handovers that the 5G system was never really originally kind of built to handle. So from my understanding, in terms of 5G core handling NTN connections, they are in early trial stages, not really widespread commercially. Right now, I think most of companies are using either LTE evolved packet core or their proprietary network cores. So that's why I think on top of that, the rapid satellite movement from LEO could cause unpredictable link quality changes. And of course, the network topology is constantly shifting, right? So it's essentially kind of like a network of moving base stations. And these fast changing conditions will kind of make it very challenging for the 5G core to keep sessions stable. So to maintain timing and to also smoothly transfer connections without interruptions. But as we know right now, also most LEO are also band type, which is kind of which means that the satellite acts as kind of like a repeater when they receive signals from Earth and then amplifying them and then retransmitting them back down to another location without significant onboard processing. But having the cell towers on satellites, like regenerative satellites, I think Vicky did mention previously on her paper, which are satellites that process and regenerate the signals in space, I think can help to process these handovers and would probably help to reduce the real-time data transmission challenge. So I do think there's been efforts in developing and innovating these regenerative satellites to counter this real-time challenge.
Anyone else?
Yeah, I can go next. So I'm fully in line with Rachel. I think she said all. To be honest, I fully agree that
Florian, I'm sorry. I can't hear you, Florian.
Yeah, can you hear me now?
Yes, sir.
Yeah, sorry for this. So yeah, I was saying that I'm fully in line with Rachel. She said most of the challenges we are facing today. The hardest part is that LEO satellites, they are moving too fast, and the fact is that today the 5G core network isn't built to update session or mission that quickly. And we are struggling. We are struggling with the handover between space and ground network, which make the operation and the handover again very, very, very difficult. We have proved with the demos that we have done with Eutelsat that it was possible, but it's just the beginning. It will pave the way, but still we need to make progress on this. We need to make progress on the fact that we need to have maybe a 5G core network more distributed and more predictive. And I think we need to use artificial intelligence as well during the predictive handover. Artificial intelligence will for sure open the door to have a smooth transition and smooth handover. And as said by Rachel as well, everything about regenerative payload and digital payload. At Airbus, we are working on it very much. We've made good progress, but still, no, we need to send it into space. We have already started, but it's just the beginning. So artificial intelligence, predictive, and digital payload, software-defined satellite, and software-defined ground segment will pave the way to have a smooth transition and handover within the full 5G core network.
Anyone else?
I'll just quickly comment in terms of my presentation and the question. One thing is just to make sure that the standards are defined, both the 3GPP but also the small cell forum FAPI interface to assist with those handovers both into cell as discussed, but also going between terrestrial and non-terrestrial as well.
Yeah, maybe I can share some perspective and experience dealing with terrestrial 5G. At this time, I think it's very exciting to start to think about when it's 5G NTN, how much more complex it becomes. Even at the terrestrial 5G side, when we deal with latency-sensitive workloads across a distributed environment, including MECs, multi-access edge computing, public cloud, and on-premise system, we see a lot of complexity. In some of our deployments, we noticed that differences in local breakout architectures, network paths, and even regional cloud behavior can actually influence performance to a large extent, and even policy and even how you place your workload. And these operational realities actually offer quite useful reference point because they kind of show us very quickly what complexity can arise when workloads are no longer confined to a single cloud region, or for that matter, a single network domain. So from that perspective, I think once we get into the 5G NTN world, this is probably how I think about it. All this complexity and issues and patterns will, appear even more strongly, especially when your connectivity expands into very diverse paths. Even without involving satellite handovers, I guess just managing varying latency on the terrestrial side is already quite complex. So I think one of the things that we're actively working towards is really to offer an opportunity to present a more unified operational approach, be they from a policy standpoint, workload allocation standpoint, architecture restructuring standpoint, and then hopefully with a more unified way of doing things, and then this becomes a little bit easier once we get into the 5G NTN world. So this is some perspective from us orchestrating cloud environment across varied environments.
Fatih, you have anything to say?
No, thank you, Kanish. They said everything, I guess.
All right.
Thank you so much. Yeah, I appreciate it.
All right. So with that, I really thank to all the speakers. This video will be uploaded on our YouTube channel in the next couple of hours, and we'll be promoting on our YouTube and also in the LinkedIn and all other social media. To the audience, please take a couple of seconds to click the subscribe button on our YouTube channel. And I really so grateful and really appreciate all the speakers. Thank you so much. Till we meet again. Thank you. See you then.
Thank you. Thanks,
Thank you.
everyone.
Have a good day.
Okay.